What's up everyone, Patrick here, and moving on to the next word problem dealing with factoring. So we have to show that the sum of squares of any four consecutive integers is divisible by 2. So because we're on the factoring unit, what's another way that we can reword this question in terms of factoring? So when something is divisible by 2, if you think about it, that means that it has a factor of 2. So for example, like the number 6, that's divisible by 2 because it has a factor of 2. Or the number 14, it's divisible by 2. It's an even number because it has a factor of 2. So another way that this could have been worded is show that the sum of squares of any four consecutive integers is divisible by 2. Or another thing we could have said, has a factor of 2. If again we relate it to the concept of factoring. So if we were showing something is divisible by 3, it means that it would have a factor of 3. Or if it's divisible by 4, it would have a factor of 4, etc., etc. So if we can maybe get a general expression for the sum of squares of any four consecutive integers, and then we could show that that expression has a factor of 2, meaning we could take a 2 out of that, then we showed that that expression is divisible by 2. Now, what is the sum of squares of any four consecutive integers? It basically means, like, let's say we start at the integer 4, for example. Well, 4 squared, the square of 4 plus 5 squared plus 6 squared plus 7 squared, right? 4 consecutive integers, meaning one right after the other, so 4, 5, 6, and 7, and then we're squaring each of those. So then the sum of that, we have to show that that's going to be divisible by 2. But unfortunately, we can't just, for example, take this, expand it, and then show it's divisible by 2, because we have to generalize it somehow. We have to show that it's going to work for all 4 consecutive integers. So how can we do that? Well, we can introduce variables, and so we could list these 4 consecutive integers generally. So what we can say is we can label them as the first integer can be x, the next integer can be x plus 1, the next one x plus 2, and then the next one x plus 3. Right? These would be 4 consecutive integers right there in general. And then this x value could be anything. Could be, for example, 1, and then you'd have 1, 2, 3, 4. It could be 10. You'd have 10, 11, 12, 13. We generalized it with a variable. So if we label those as the 4 consecutive integers, what's the sum of the squares of those going to be? Well, we would have to take the first integer, square it, plus take the second integer, square it, plus the third integer, square it, plus the fourth integer, square it, like that. Okay, so that right there would be the general expression. It's not expanded yet for the sum of the squares of 4 consecutive integers. So what we have to do now is we have to expand all of this and get an expanded and simplified expression, and then see if that expression is going to have a factor of 2. So if we do that, we would have x squared plus, if you take x plus 1 squared, which would just be x plus 1 times x plus 1, FOIL all of that out, simplify, you'd end up with x squared plus 2x plus 1. Okay, I'm not going to go through the work for that. You should be fairly comfortable going from here to here. And then x plus 2 squared, x plus 2 times x plus 2 would be x squared plus 4x plus 4. And then x plus 3 squared would be x squared plus 6x plus 9, like that. And now what we want to do is we want to simplify all of this. So the like terms, x squared, x squared, x squared, x squared. So there's 4 of them. We'll have 4x squared. So those go away. Let's keep track here. So we got 2x, 4x, 6x, which would give us what? 12x. So those go away. And then we'll have 1 plus 4, which is 5, plus 9, which would give us 14. So we'd have plus 14, like that. So this here is the general expression for the sum of the squares of 4 consecutive integers. And so you could even test it if you had time on a test, for example. We can pick, let's say we pick an x value of 6. So that would be the first integer. So we would have what? 6 squared plus 7 squared plus 8 squared plus 9 squared, like that. So we'd have what? 36 plus 49 plus 64 plus 81, like that. These two would give us 100, 149, and then we would end up with 149 plus 81, which would give us what? 230? Right, if we did it manually. And then if we check that x value of 6 with this expression that we got, what would we have? We'd have 4 times 6 squared plus 12 times 6 plus 14, like that. So this would end up being 4 times, we have to do the exponent here first, BEDMAS, 36 plus 72 plus 14, like that. And so 4 times 36 would give us 144 plus 72 plus 14. This would end up being 86. 86 plus 144 would give us that same value of 230 that we got over here, right? So even though we just did one check, it doesn't guarantee it's right. We could be fairly confident, and it would work. So for anything, so if you let that x value be 21 as that first 4 consecutive integers, right? If you took 21 squared plus 22 squared plus 23 squared plus 24 squared, whatever that value is, and then you also plugged in 21 for x, you would get that same value for the sum of the squares. So this here is the general expression, like that. And so what we have to do is show that it's divisible by 2 or has a factor of 2. Well, notice, can we take out a 2? 4, 12, 14. All of those have a factor of 2. So we could take out a 2, and what would we be left with? 4x squared divided by 2 would give us 2x squared, plus 12x divided by 2 would give us 6x plus 7, like that. So because we were able to take out that 2, we just showed that this has a factor of 2, meaning it's divisible by 2. One thing I want to mention as well, in this particular case, the 2 is actually the greatest common factor, which is also nice, but that's not necessarily always going to happen. Like, for example, let's say that we got, let's say that instead of the 14, let's say that it was 20. For example, okay, if you had something like this and you took out the greatest common factor between 4, 12, and 20, it would actually be 4. Okay, but you wouldn't take out the greatest common factor because we're just showing it as a factor of 2. So you would still take out a factor of 2 here, even though in this case, it wouldn't be the greatest common factor. So that's another thing I want to mention. So you'd end up with that right there. You could still take out a 2 from here. Right? The greatest common factor is 4, but since we're trying to show that it's divisible by 2 and not 4, we would just take out that 2. But in this particular case that we're working with, the 2 did end up being the greatest common factor, but that's not always going to happen. So whatever you take out over here, it depends on what you're showing that that expression that you're dealing with is divisible by. Right? So we took that general expression, expanded, simplified it, and then because we were able to factor out a 2, we showed that it's divisible by 2.